Hello everyone and welcome to Handmade Hero Show, where we code a complete game live on stream. We are going to take a look today at cleaning up our sort of on-demand asset importing. And really where we've gotten with that is we did all the heavy lifting. We even have now a tool that can manage our file formats for us and all kinds of stuff like this. And you know, the place that we've kind of gotten to is we now really have to start deciding what we want our asset specification to be, what we want our forward specification to be, where the game says, I want to put this asset in this place. And this is a really tricky problem. It's a very tricky problem because it's not the kind of thing where the right answers can be measured in terms of certain specific things that are easy to understand based on the other sorts of things we've done on Handmade Hero. It doesn't have a lot to do with performance. There are some performance implications, but most of the time we have plenty of CPU power around for matching assets. It's not really a huge deal. It's not really a space issue. Assets, typically the bitmap data or whatever else is the asset that you're talking about. Typically the asset data itself is just much, much larger than any of the metadata associated with it. So it's not a storage concern. So we can't say let's optimize for storage. We can't really say let's optimize for speed probably, because both of those two things, really it's not going to matter very much which one we do. We have the flexibility to do either. It's not the kind of thing we can really look at as an API problem. And the reason for that is because a lot of the things we would look at for an API problem just aren't involved here. This has to do with communicating between a programmer and an artist, basically, not between two parts of code. And so what we really now have to focus on is something a little bit more existential, a little bit sort of further outside the boundaries of what we normally talk about, and just go towards a vague kind of exploration of look, if we just kind of follow the API design principles loosely that I've talked about in the series before, meaning focus on the usage code, what does it look like, what would make the most sense for us to type in here. Take a look at that. Take a look at the other side, the side that's doing the importing. Where is it getting its data from? What kinds of things are the artist making? That sort of thing. And just try to see if we can guess what the right sort of thing is for all of these kind of competing, all of these things that are in tension with each other. What makes the most sense for us? And we kind of know that the tagging is a nice flexible way to just say, look, we can put a bunch of stuff onto an asset and say, here's just some values and some tags that say what those values mean. We know that we can do that and that it's very flexible and allows us to add new things. That's probably good. But the question is, how do we use those tags to actually create a system that works well on the other side, or on both sides, really? So how do we know what the tags are for an imported asset? And then when we load something in, how do we process those tags into some kind of a state that allows the people who are using the asset system to efficiently talk about the kinds of assets they need and get them? And one of the things that we might want to consider in the mix here, which I mentioned a couple of times, is if this is something that people continue to learn from in the future and use as sort of like a, because like I've said, all the code for Handmade Hero will be released in the public domain eventually. At that time, if it's sort of used as a playground for things, people trying out various algorithms or learning and experimenting with low-level code or whatever, it's nice to be able to have them be able to trade stuff around. Like, it'd be nice to be able to say, here, I posted some new mods to Handmade Hero, and here are the sprites that go with it. It would be nice if those could integrate into the system cleanly and not require a lot of rewrites of the asset matching system. So it'd be nice to have a way of exposing things easily when you add something to the code base, having it be pretty easy to expose it such that people can write sprite sheets for that and have that flow through the system without everyone having to change the way they're doing things or who knows what, right? So that missability would be nice. And you could even think of it a little bit more broadly and say, if we eventually allow multiple DLLs to be loaded. So, in the future, let's suppose we're done with the main part of the game and we say, what if we want to break this into something easily moddable? How would we make it so that you could load lots of different gameplay DLLs and have them all mixed together, right? Well, if we want to do something like that, what implications would that have for the asset system, right? Because now you've got multiple people, all of whom are talking about potentially different sorts of tags, maybe even tags that only they understand and know about. How would that come into play? What would that mean, right? So we kind of have a lot of competing concerns there, and it's difficult to really think them through. So what we want to do is just be aware of that, see what kind of progress we can make. We've got some obvious cleanup stuff we can do. I might start with that today. But our goal with today and tomorrow is to sort of get to a point where if, maybe we're not done with it, but at least we sort of understand what we're going to do to finalize that matching in a way that we think will work going forwards. It doesn't have to be completely final. We can always come back and edit, but something that we at least believe to be that we could plausibly say here, this seems like we could ship with this, right? We just need a convincing argument. All right, let's go ahead and remind ourselves of where we are. So what we did last weekend is this is the game running right now, right? And we can sort of see it's running in debug mode, so it's slower than normal. But this is what we're running right now, and as you can see, it's got the hero in there with the correct sprites, as it should. That was actually pretty cool, because what we did is we actually made an editor binary that would allow us to mess with our art files, right? It's called HHA edit. Go to the data director here. This HHA edit lets you do stuff where you can actually work with the data files. And what we did is we told it to upgrade all our old V0 art files to V1 art files. What that allows us to do, and it's pretty cool, is it basically means we can stick with a binary asset format that's really easy to work with and doesn't require any parsing. But we also have this external tool we can use to rewrite it or maybe merge things in the future if we'd like to, that sort of stuff. And that's very powerful because it means if we want to upgrade our binary file format, we don't have to have our game understand the changes. The game can just move to the new version and only understand one version, and then HHA edit can just upgrade the older version files to the newer ones. And so what that lets us do is that lets us settle on a V1 file format that's whatever we want it to be, and then we can just upgrade all our V0 files to be V1 files, right? So we haven't necessarily baked this V1 format. We can change this V1 format still. And kind of go from there. And we may want to do that. We may want to add additional things to it. But that's where we're at right now. We have that flexibility, and that's a really good thing, right? Okay. So what we need to do now, we got a couple things we want to clean up. But what we need to do now is we'd like to start getting this art into the game, and we can start with some pretty basic stuff, right? We're looking at a world that's mostly doesn't have art in it, and that has the wrong art for the hero. It's the old artwork for the hero. And so what we want to do is be able to do stuff like put in, say like floor textures, right, on these floor cells here. We might want to put walls textures and ceiling textures on these tiles, right? Coming out a bit more, let me zoom out here. There we go. So coming out a bit more here, if we wanted to go ahead and start to put other characters in these rooms, maybe have someone who walks around in the hallway. How would we specify which sprites they were using, right? And so if you take a look in the Handmade artwork stuff here that we just have a ton of stuff that we can bring in. So we've got a lot of characters we can bring in here, right? Lots of different characters, all with sort of different styles to them. I love the braces in this one. So how do we get these characters into the game, and how do we specify what they are? That's the question for us, because now we know we can load them all and put them into our system for artwork. But the question is just, how do we actually refer to them, right? Okay. So with that in mind, I think there were a few things we hadn't quite finished yet, and so those are the things that I think I'd like to focus on today, because we don't really quite need to run up into the tags issue, and I'd like to put that off as long as possible, because that's it's not about writing code, it's about making some hard decisions, and that's always a little bit frustrating, right? Because you don't really know if you're doing the right thing, and you gotta do some experimentation. But what I'd like to do first is I'd like to just go ahead and patch in the stuff that we're missing, that we didn't have a chance to finish, and I'll just quickly go over what that is. So if you remember correctly, we have this check for art changes. It actually runs at startup, and what check for art changes is going to do is it's going to look through all of the files, and it's going to see whether we understand what those files are. And we wrote all this, and we sort of just put it to the side. Like this is our sort of runtime updating part. And we can sort of see what it does. It loops over a hash table and looks to see whether or not the particular file in question that it sees is a file that we know about. And if that file is a file that we know about, we go to see whether or not it has changed, right? We use the file date as a way of saying, look, do we have to reload this thing? Do we think we have to reload this thing? Or is it probably the same because we've seen it before and had the same file date? So it's probably the same file, right? And that's what we're doing. But we didn't really have any way of making that persist. That was what stopped this from being complete. So when this happens, we stored this information into these this hash information stuff here into the hash table. You remember this hash table was a nice little convenient thing. Where is it? Here, as a source file. And this asset source file information here, what this did was say, hey, here's the source file and here's the grid that said, what assets we imported from that. This is just a very simple structure that lets us kind of get from a Photoshop export, a PNG that Photoshop exported, to the assets in our asset system. It's not persistent. And if you remember, when we stopped and we moved over to updating our file format, the thing that wasn't working yet was that persistence. If you ran the game with an importable asset file, then what would happen is it would say, okay, I'm going to import all of these PNGs that you told me about. We actually restricted it to just ones that were hand things so that we could not wait as long. So we were just importing a few. It would import all of those into our asset system, and that worked. Great, yay for us. But if you close the game and restart the game, it would import them all again. Why? Because this is memory resident only. So when you close the game, it goes away. When you run the game again, it sees those PNGs. It's like, I've never seen these before. And it's right. As far as it knows, it's never seen them before because it only has like short-term memory, right? It only knows for that run of the game what it's seen before. So what we wanted to do was make this persistent. And what I did when we sort of updated that file format, and hopefully I mentioned why I was doing this, but maybe sometimes I forget to say why I do things, but hopefully it's clear most of the time. What I did when we were updating it is I gave us a way to mark that. So this HHA annotation thing that we can now, in our new file format, put on every file, right? Optionally, it's just an additional field that you can stick on every asset. It allows us to say exactly this, right? It allows us to say, okay, here is the file date of the PNG it came from. If we want to, we can even add a checksum, right? We can cover why we might want to do that and optionally do that. We don't have to do that, but we got space for it if we want to. We can store the name. We can store what the asset was called and what its description was, and if there was an author. Again, we don't really know that information right now, but if eventually we wanted to tag things like that, we could. And so you can kind of see where we're going with this. We now have a place that says all of this information. It says what the sprite sheet was, location-wise, right? All of that stuff. Okay. So hopefully you can see why this is why I put this in there, because this is a way for us to solve the problem of storing this information. There were two ways I could have solved the problem. One way is to store a separate file that would keep track of this information. We could have done that. Why did I decide not to do that? Well, again, because I really just don't know how these files are going to end up getting used by the world at large once this game is released. You know, it could be we release Handmade Hero and no one cares, right? It could be we release Handmade Hero and people are starting to use it for educational purposes in some ways, right? And maybe it's helping people get interested in low-level programming. At that point, I would like this file format to be, again, a way that people can share things with each other and learn about low-level file formats by looking at it, right? And so what I wanted to do was like, okay, instead of storing a separate file so it won't properly transport when you send someone an HHA, right? I want to make it so that when I send someone an HHA, they get the import data with it. Because I feel like that might be a little bit more powerful, a little bit more useful. And furthermore, if you can tag these things with names, descriptions, and authors, again, that fosters a certain sense of understanding of what's in the file and ability to share them with other people in a way that you can look and go, oh, okay, you know, this was made by Carl, and then this one was made by, you know, Mary, and this one was made by, you know, someone from the chat. This one was made by Sherlock93, right? And so I think that just is just a better way to do it based on what might get used for in the future if it does get used for educational purposes. If no one cares about this after we're done here, and it was just something that we all did together and had a good time doing, that's totally fine, but I also want to be prepared in case it ends up being something that people do learn from and can share with each other. So let's take a look at how we might do that. We know we have this HHA annotation array. At the moment, we're really not doing very much with it, and that's sort of what we need to rectify. We need to weld in our new understanding of what the file can do into the asset loader, because right now the asset loader just doesn't care. And if we take a look here, like I'll move this over to this side, and let me bring the asset system up over on the other side here. If we look at how these files are loaded, what you can see is we just load the assets, but we don't care about the annotation. And why should we? We don't have any reason to, right? So what we want to do is we want to say, okay, now let's start paying attention to this because we do have a reason to. We're going to make this code aware of where its assets came from so that it can now make correct decisions on import, right? So that's what we're doing. We're just updating this code in a way that allows us to use annotations from the file so that it can avoid re-importing things it already imported on prior runs of the program. And that's all we're trying to do here. That's what we want to get to. All right, so if we take a look at what's going on, you know, allocate game assets, it comes through and it reads all of the HHA files that it currently has. This is that sort of check to see what's going on there. When it does this, you can see that it kind of snaps an asset base and a tag base and an asset count and a tag count. Those are there to allow it to load the asset and tag arrays correctly. What we want to do here is also respect the fact that the annotation array, which has the same number of assets in it as the asset array, may be there and we may want to load it. That brings us to this piece of code. We have the information we need to allocate it because it's the max asset count. We want to have a slot for annotations that exactly mirrors our asset count, our asset array. So all we're really talking about here is in here we would have, in addition to assets, we would have annotations, right? Now the question is, do we need to bother doing that? And the answer is, well, we don't really need to allocate it that way. Why is that? Because if you take a look at what we would actually be doing with that asset array, we know that it's going to be stored with the assets proper, right? We know that we're essentially going to take these and store them with the assets themselves because that's the only time we're going to be using them. So if we want to, we can just weld that information in because we know we're already storing things slightly differently from the way they appear on disk. So if I take a look at the H file here, which you can see, right, we've got all this information about the asset. This HHA asset here, we can just expand it to say, hey, store the annotation as well, right, when you load it. Store the annotation as well. So then we don't really need an additional push array. We'll just create the space we need right off the bat, right? We'll just do that first. And so if we go ahead and take from here, right, excuse me, If we go ahead and take from here, when we come through this part of the code, when we do our data reads, we can now make another, right? We've got a temporary data read for those HHA assets because we're pulling them out and putting them into sort of a new structure. We're loading them kind of piecemeal there. When we do that piecemeal merge load, when we do that, we also have the option of pulling out the annotations and loading them that way, right? So we can do it either way. We can have a parallel array if we want to. We can have them welded if we want to. There's not a lot of issues to either one. I'm just going to start with this one because it's more straightforward. If in the future we sort of screw around with this a little bit and end up doing things more direct load-like, where we do more direct loading and less fussing at the merge stage, which we could do. If we want to do that, then we would play with this more, right? But at the moment, we don't really have to worry about that nearly as much. Okay, so how are we going to do that? Well, right here where we do platform data read file like this, we read the asset array, and it's really easy for us to just load the annotation array, right? It's literally just a case of changing from loading one place to loading another, and changing from loading one struct to loading another. Right? That's it. I mean, that's the entirety of it. And so all we really need is a place to put it temporarily. Since we already have temporary memory, it's free for us to do this, right? We can just go ahead and push on another temporary array, and we can read it in. So when we read these two arrays in, we now have all the annotations ready. And when we pull them in here, we can trivially just use them, right? And it's exactly analogous. There's no difference between these two. Like so, right? Now, there is one thing we have to be aware of, which is that although the assets array always has to be there, and in fact, we just check to see if there's an asset count to make sure we need to load it at all, but if there is, then it's got to be there. Annotations, not so, right? We do not need to do anything with annotations in a file. It can have the annotations stripped. So if I want to, I can support that pretty easily along this code path by saying, look, there may or may not be an HHA annotation array, okay? In some cases, if we find that there, if we find that this does not evaluate to value, it's 0 instead of a valid offset in the file, then we'll just say, hey, look, there isn't one. So then when we come through here and we say we're going to point at one of these, what we can do instead is say, all right, let's just pretend that it's 0 for now. And then if there is an annotation array, then we set it to something. Okay? So off we go. We can also make it be a null annotation. Maybe that's easier. The null annotation can just be, you know, something that sticks around. It's just like, hey, here's our big old 0. And so what we could do is just point at that, right? Just a big old block of zeros. So that way we know that the annotation is always valid in here. It just may be a block of zeros, but it's never a null pointer. We don't have to check for that. So we can just check for the actual parts that we want when we want them, and that will support both cases, where we have an array and where we don't, and where an annotation has or doesn't have certain of the strings that are there, right? So if we look at what goes on in here, you can see here that we track the asset data. When we put it in there, you can see that we assign it here by the same token, right? We can assign the annotation, right? So we can do this trivially, where we just assign that annotation, and we now have exactly what we wanted for that. Once we have that annotation information in there, it's now the main problem that we're going to have is we have to now rebuild our source file. We need to make this source file information work again, because right now we don't have any way of reconstructing this. We have to reconstruct it from the annotations, right? So our goal now is to build this asset source file information up again, where we can sort of say, look, let's rebuild for every asset. Let's go ahead and rebuild sort of the hash table we were using. Now we have a couple different ways that we can proceed. So right now what we do is we have the asset source file, and we then just use this. Well, you know what? I'm not going to go into that part. Let's just say we're going to use this. So what we need to do is we need to look over all of our assets as we merge them in, and we need to build an asset source file sort of backing store that tells us where these things came from, right? And we need to sort of figure out some way of reconstructing that information. Now, we have in the file format a bunch of the stuff we need. We know we need the source file date. In fact, let me just bring those both up together so you can kind of see them here. So here is our asset source file information. You can see that it has a grid here. This will tell us where in the grid various assets go. It's got a file date. We've got that too. And it's got a base name, and we've got that, right? These are not particularly relevant to the asset source file. So they don't really need to be stored in here. Those are just tags that go with any particular entity, any particular asset. Excuse me. So really what we're looking at primarily is we don't really have to load these, right? These don't have to be loaded. They might have to be saved, but they don't have to be loaded. Because we don't really care. We just have to preserve them so that if we load an asset and rewrite the asset, we need to remember to repoint to the correct name, description, and author. But otherwise, we don't care. However, the source file base name offset, we do need to load that. That is important for us to load. And when we load it we're going to have to look at that name, right? Now, this creates a bit of a dilemma for us, and that is that we haven't done a particularly good job looking here at minimizing the amount of data read we're going to have to do. And why do I say that? Well, suppose this file had 10,000 assets in it, but they only came from a total of 20 files. Well, if right here, I mean, the easiest thing for us to do, right, is slap this platform data read directly into this loop. So every time we get an asset, we just read into a little buffer what the file name was. We grab that, part out of the file, and off we go. It's plausible that we can do that, but that basically means that we're going to bite an entire kernel transition, right? We're going to call into the operating system for every asset. So if we have to load 10,000 assets, we're going to hit 10,000 times. That's not a very nice way to do this. Especially because if you look at what happens here, we only really issue three reads, tags, assets, annotations for every file. So if a file has 10,000 assets in it, we only hit 3 reads, right? It's not great, You know what I'm saying? It's not great. And so to me, that kind of suggests what we would like to do here is perhaps actually introduce the notion of a separate array for source files, right? Because that is something that actually needs to get read at runtime. And so because it's something that wants to get read at runtime, it kind of seems like the sort of thing we may want to deal with more directly there. And I'm just not sure whether that's, something we care about or not. Here's what I will say. We could just proceed without doing that. And the way we would do that is we wouldn't bother building the source file information if this isn't an editable file, because we know we don't care if it's not an editable file, right? So meaning if this file isn't open for updating, we can add a tag that says whether a file's available for updating, right? Like that's something that we can do. If we're not allowing updating on a file at the moment, we can just not process that data. And then if we are allowing updating on a file, we can process the data. That means it will be fundamentally slower to load in that kind of dev mode because we're hitting a lot of those asset loading calls that really should just all be done as one call. But it would not affect the runtime of the non-development side of things. So if you launch the game and you don't have anything open for editing, it wouldn't affect things. I'm out of liquid. It's a horrible state to be in. So I really can't say which of those two I should pick. Here's what I'm going to say. Rather than copying the code base, I'm going to do the simpler one and just read from the file in the case where the thing is open for reading. And the reason that I'm going to do that is because nowadays disk access is getting a lot cheaper. You know, you get M2 drives that are just like absolutely sick at reading. And we're going to be hitting the cache most of the time anyway. So I'm just going to say, look, let's see how bad it is. And if it gets bad enough, we'll fix it. But I won't overcomplicate things now in a sort of a premature attempt to avoid that eventuality. I'll just note it in the code and we'll go from there. And we'll just say, look, this only happens if you're in dev mode. So we'll put an if around it, and I'll also tag it to say, look, so at the moment we'll just say that, and you know, maybe I'll even make it a to-do. So we'll just say, look, maybe we want to look at this, and we'll kind of feel out how it goes. You know, I think that's a reasonable decision. So what I want to do here is I want to have some notion of whether or not this file has to be edited, whether this file has editing allowed, if you will. So I'm just going to say, like, if file allow editing. And so that will give us a way to mark our files specifically, and anyone who wants to know whether a file can be edited can just look at that one flag, right? So what I'll do here is I'll say, look, we only have one file that allows editing at the moment. It's this one. All the rest of them don't. So that'll make it easy. We would only trigger this path in that one case. And then we'll do the load here for the asset. We can find out what that asset file is. What I'm going to do, again, we've got a temp memory. So what I can do here is I can literally just make a quick little temp space for this thing. This is the asset's source name, right? I could even temp around this, but it's probably not even worth it because it'll get cleaned up at the end. But, you know, if we cared about the fact that we're loading 10,000 things, so we're, you know, wasting, you know, a megabyte of memory here or whatever, we could clean that up as well. But we don't really care. It's probably faster to just push on there and then come back to it later. I don't know. It's hard to say. Cache things, blah, blah, blah. You know, you could try it either way and see which one's faster for you. But so when we come through here, what we want to do is say, hey, look, for this annotation, right? We want to know like the file name count, right? The source file name count, and we want to load. We want to make an array here that we can load into that's going to tell us that, right? And I think I don't really remember exactly what we decided here. So it looks like we've got a null terminator there as well. It looks like we wanted a null terminator. I'm not sure what we did there exactly, but you know. Looks like what we wanted. So as soon as we want a null terminator, I'm also going to just give it the padding, right? Here's that source file name. It's going to get loaded in. The source file name, I'm going to put the terminator at the end of it after it's loaded. I could do it after it's loaded. I mean, it doesn't matter when I do it. Either one's fine. And then when we load this here, we know we've got an offset that we want to load from. And so and we know we want to load this many characters, right? So when we load this in, I just have to make sure I specify what exactly what our two read data pieces of information are. So when we do read data from file, right, we have to pass it the location to read from, and then the amount to read is how we did that. So like I said, we know the amount to read, it's just the name of the thing, but we need to know where. Well, we know that as well because we have the annotation. So in fact, I can do it this way. So from the annotation, we know that the source, where is that here? We know that the source file base name offset is the location that we actually want to read from. And then again, we know the source file name count because the source file name count can come from the exact same place, right? So we can load these source file names in. Once we read them, we just need a place for it. Well, that's exactly what we made right here. So there it goes. Now we've got that name from the file. And what we want to do is we want to just create the placement information for this asset now, right? So if we go back and look, we've got this asset source file. What we want to do is say, hey, the asset source file, in this case, we need to say something here where we pass the source file name in and it does the hash lookup for us. So we kind of want that to happen here. And then it will give us back that source file. Then what we want to do is look to see whether the location in this grid is occupied by somebody who is a newer version than us or not, if that makes sense. So we need to see when we go look at this asset import grid here, we need to see whether or not there's already somebody in there that has a lower precedence than we do, right? Because we don't, you need sort of there's a primacy number, and we need to see whether or not the primacy number is higher or lower than ours, if that makes sense. So when we look in there, what we're effectively going to do is say we get the source file back. We're going to say, all right, if the source file asset indices for wherever we're looking, so we need grid Y and grid X. For that asset, we want to say, we want to have some kind of a query which says takes precedence over, or like precedence is lower than, right? So what we want to do here is say, look, here is the asset we're talking about, okay? It's this asset index here. And then we know our precedence number because that's something that we will have loaded out of our tags, right? So I probably want to pull that number out here so that it's available at all times because it's going to be relevant to us as we're doing sort of asset merge sort of stuff. So we probably want to know when one comes in here. There is another way we could do it. We could just remember everybody, like all the assets that happen to be mapped onto this grid location rather than just the most recent one. I'm not sure how we want to do that. I don't know that that would really get us anything in particular. I don't really think it will. So I'm just not going to bother with that. So what we want to do here is see if the precedence is lower than, you know, the other thing we could do is just make this be an error. Like you're just not allowed to do it. So we could actually just say, hey, if there's already something in this slot, you've got an error and we need to just let you know. that you've got to use HHA edit to like delete an asset or something because you've got two assets open for editing that both came from the same sprite sheet, apparently, right? So what I might do is say, all right, look, if this equals 0, we're good to go. If it doesn't, it's an error, right? And if you remember correctly, we actually have some error reporting in here, right? You can see that we've got sort of this outf to match errors thing. So we can, if we want to, sort of have the notion that there is an error, like an error stream that's coming. And because we were previously like, you know, here's the error stream stuff, it just so happens that this error stream is actually in the right place for that, right? So we can, I think, just literally output the error to that file and it all just works. So I don't even need that to be a to-do. I can just do it, right? And what I can say is like asset, you know, %u and %u both occupy same slot in sprite sheet and cannot be edited properly. Something like that. And then what I could say is like, well, you know what I should probably do is say, here's the sprite sheet and here's the grid location. So I could sort of print this out almost like C style, C compiler style, right? So this way we can say, here's the source file name, here's the grid Y and grid X, and I should reverse those two because we're in human readable form here. So there's the source file name, the two grid locations. We know which two assets we're talking about, because we know this particular asset index is this. And the other asset index that was in here, do we know? Well, I guess so. When we are actually looking at assets, I guess we can just use this. So actually, we know which asset index it is there. So I can actually get that asset out. So that would be the conflicting asset is this one. Maybe it's a little bit better. All right. So if the grid, if what's in there currently is 0, right? And I could do it this way as well, just to make it a little bit clearer. So, you know, we can say, all right, in that case, the asset that's in this grid is my asset, right? So replace it. So that works. But what I can also do here is say like, okay, hey, if we did find a conflict, then whatever the one that was in there right now, let's print out what its asset index was too. So then we've got, all right, we've got the asset index in file, and we've got the conflict asset index in file. So that tells you the two assets in that file that were wrong, and off we go. So I think that's all good. Probably that will print out the error into the source file's asset error buffer. And that way, when we actually have a nice way of printing those out somewhere, which we'll want to do eventually, we will have this error reported to us properly. So this will place it into that file correctly. There really isn't anything else we particularly need to do here, except for the fact that when we are importing these assets in, that file date there, we could end up with a conflict. Now, this is kind of annoying. But it's just the way it is. So we need to set that file date to the lowest possible file date. So what we want to do here is say, when we grab this file, we need a thing here that's like, you know, look up file or whatever, right? And then we need to say, look, if the source file's file date is greater than our file, than what we think the file date should be, right? Because we have an opinion about that, right? Our HH annotation says what we think the source file date was. If it's higher, we need to set it to ours so that we always pick the lowest source file date, right? And then we can set the checksum if we want to. Again, we don't have that right now, but the file checksum equals HH annotation source file checksum. So in this case, you know, when we, file data, try file date. So in this case, when we look at that information, we say, okay, when the source file comes back, if for some reason we've got a mismatch here, we need to set it to whatever ours is, right? And we could do this a little bit more strategically here. Maybe that's stuff that kind of needs to get handled in the lookup or whatever. So what I can do is I can also just pass those along in case it wants to do more complicated conflict resolution. Maybe we do it like that, and it gets handled in the lookup, right? So we've got the date and checksum, and those kind of flow through the pipeline automatically, right? So once we've done that, we are ready to go. That pretty much imports all of that information in. And so we just need our lookup file or whatever function, and I think this code path is good to go. What we don't have is a thing on the other end that will properly save this information into the annotation slot for new assets. So that part we still have to do. And it's not very difficult because we kind of already have it all set up to work with the asset arrays. So it's pretty straightforward, but we got to go do it, right? So I'm going to do that, but first let's take care of lookup file or whatever. What we can recall here is back in check for art changes, here is the thing that does what we want. So really all we have to do here is extract this code out from what we're doing in this scanning loop here. So we just need to extract this code, and we need to make that into like a callable thing so it can be done from more than one place, right? So what I'm going to do first is sort of pull this out here and make this be something we can call. Again, got some compression-oriented programming here, right? Just say, look, we see ourselves using this multiple times. Let's make it into something we can. And most of the stuff here, totally straightforward. What we don't have is the hash value, right? So we need to pass that hash value in, and that means we're probably going to have a two-layer thing here because sometimes people have the hash value, other times they don't. So anyway, this is going to be like a get or create asset source file, and this will return that asset source file. We know that we're passing a hash value here that will allow us to access it. We also know that we need the base name and the assets, right? So then we flow through here. Okay, you can see us updating the hash value like so. Can you make that a little clearer there? We pass in the unmodded hash value. We produce a hash value that has been modded properly. We then go ahead and search for the match. If we find the match, we're done. When we look through here, if we did not find a match, we create a new one, and then we return the match ready to go, right? So we got there's more to it than that potentially, but that's mostly what we're looking at here. So then what I want to do is fill out this in terms of this other file, in terms of this other function. So here, again, we don't actually want to do this anymore now. I just want to pass the hash value in like so. And then the question is, well, where's the base name? The base name is in here, right? There's the hash value, there's the assets. Here's our match. And so then this stuff doesn't really have to execute now. By the way, this is like that. And this is like that, right? And that all looks fine. So then what we want to do is say, okay, this code goes away. We can just get the match directly, like so. We want to assert because we're basically saying, look, it has to succeed. It will create a new one if it doesn't find one. And then we'll proceed to do some stuff with it, right? Okay. So that's most of the code that we actually wanted. What we want to do now is say, well, okay, the asset source file version here, get or create asset source file. There's another version we may want of this that does something slightly different. Here we just have the base name. We don't know what the hash value is for the base name. We also have the file date and the file checksum that we're passing. And what we want to do here is first produce the string hash. And you can see here the update string hash function, where that came from, this right here. I don't know that we have a thing that hashes a whole string. We don't. So we should probably make something that just hashes a whole string, where we just pass a z string here. And this is just as simple as saying, all right, the hash value equals 0 to start with, right? While star z, update string hash, hash value, star z. We can even do that if we are so inclined, right? So that lets us produce the entire string hash in one go, which is something we do want to do. You can see here we're producing it in line to this so that we don't have to look at the string twice. Arguably not necessary to be that optimal about it, but it doesn't matter. That's just how it is. We don't need to undo it. So here we know we want to take the string hash of this base name. So then we can do asset source file results equals get or create asset source file. We can pass that in here. We know we've got the assets, the hash of the base name, and the base name. And then what we want to do is, again, take a look at the date and checksum information on the file. So what we want to do is say, look, if this file's file date that it's got in there is 0, so, you know, this right here, if the file date is 0, then we know it was new. It was newly, we're the first people creating it. So if the file date is 0, we want to reset it. And we also want to reset it in the case where we have an earlier one, right? So if it's 0 or if the file date is on the one we find is greater than our file date, then we need to reset it. And the reason to prefer a file date that's lower is because, if you remember, the point of the file date tracking is to make sure that we don't use old assets. If we have two assets that came from a source file, and one of them is saying, well, I was from date this, and the other one's saying I'm from date that, right? What we want to do is use the earliest date possible, because maybe the asset file has been updated, and if we use the later date, that earlier date asset risks not getting its new version. There's no harm done in re-importing something, right? So we want to make sure that we're always preferring younger dates in terms of when files should be operated. Younger dates? No, older dates. More elderly. We want the older file date, which is a lower value, right? I don't know how you want to say that, but we want dates that are lower, even though that means the file is older. A little confusing. Anyway, so we want to prefer those, so we do prefer those here, and then this is the file that we'll call in the case where we're actually saying, look, here's the data, here's the date information, stuff like that, that we actually have. So now we know what lookup file or whatever actually is, and it's passing exactly the things we want here, just like so. So we just go ahead and suck those up into the function call, and now we're good to go. So now if we look at what we're doing here, what's this, game assets actually? Yeah, game assets, don't ask me why, as opposed to like the other kinds of assets we have apparently. Anyway, if we go ahead and what's wrong here? Get a create asset source file. We pass the assets, game assets. The base name gets passed second, right? Yeah. And then the string hash of the base name gets passed there. That sure looks like it. Is the string hash of not produce the right value? It doesn't. All right. So, annotation index is just a typo here. Obviously, we don't actually need an annotation index. It's just an asset index because they are parallel arrays. If they exist, they're required to match, right? So here we've got U64s. I must have accidentally said U32 there. I didn't actually mean for it to be U32. I want it to be U64, so I apologize for that. It's supposed to look like that anyway. We then have the grid Y, grid X stuff. I wrote those out in shorthand, and really we have that information. We don't need to compute it. It's just it's a little bit longer handed. It's sprite sheet X from the HHH annotation, like so. And then here, this is not file. That's supposed to be source file, so that's a bit of a screw up. Glad that got caught. And that's it. So that imports all of the annotation data that we actually care about. The rest of it just leaves as pass-through because we don't need to know the author or the description or any of that stuff at the moment. Maybe we want to load those later for some other reason in some kind of editing mode or something, I don't know. But at the moment, we don't care. We just need to preserve them, and this will preserve them so long as when we actually go to write assets out, we write out their annotations as well, which we have not done yet, and that is the last thing that we want to do to support that editing. I think that's really it. I can't... Oh, wait, there's one other thing I want to do, and that was downsampling. So after we finish this, we'll do downsampling as well. Yeah, sorry. So if I want to do that, let's just go ahead and go to the place where we actually write these things out. So, you know, we have sort of all of this done already, right? We already did the write changes. Here it is. And we also have write asset data, right? You can see it doing this stuff here. This is really all we're going to need. So when we come through here to do write modifications to HHA, now is the point where we can make this work with the new file format and include the annotations with it. And I think that's really the last thing that we need to do there in terms of bookkeeping. I think that's the end of our bookkeeping, you know, other than debugging, obviously. But off we go. And so what we need to do now is adapt this to the fact that we don't have to use asset types anymore. Asset types are not relevant. It's just tags and assets. And what we need to do is expand this to put in the annotations because we want our annotations array to be preserved now. So really we're just replacing one array with another, and that array happens to be one that we actually wanted instead of one that we don't. So here's our annotation array, and here's our annotation array size. So we know we need to write that out. The question is, where is it going to come from? Also, let's take a look here. We know that we're doing our tag build up here. There's nothing probably specific that has to happen in this. I would like to assert that this file allows editing, right? Because if this was set to false and we got to a write modifications call, that seems really bad because then we're about to overwrite data in a file that we said wasn't supposed to be edited. So we probably want to alert ourselves in debug mode to that fact because something's gone seriously pear-shaped at that point. So when we come through here, we build up how much tags we want. We know all the rest of the information that we actually need. And what we do now is instead of that asset types array, I just build the annotation array size. And again, that's just going to be the asset count times the size of the HHA annotations. And that's good to go. We then come through here and say, again, don't need this. Annotations is not something that gets counted. So if we take a look at the header file now, right, we got tags, assets, annotations. We don't need a count for annotations because either it's 0 or it's a valid offset. That's all the information we need. We know that it has the same number in it as asset counts if it exists in the first place. If it doesn't exist, it's just not there. If it does exist, it's got as many as those in it. So no worries there. So now we just put the annotations in here. You can see me setting that up here. So what we say is like, all right, header.annotations. So this is the tag array size here, and this is going to be, assets plus asset array size, right? So we just say, all right, the tags start at the watermark. The assets are, the assets are wherever the tags were plus however big the tags were, and the annotations are wherever the assets were plus however big the assets were, right? Very straightforward. Tag those on. We can then go ahead and get those location, not those locations. We can then go ahead and get space to build those before we write them out. Again, all we have to do here is just make sure that we allocate an additional one for annotations, replace the asset types with that. An asset type count. There shouldn't be an asset type count also, so I need to get rid of that, so that's gone, right? So we go ahead and do that. We don't have a dest type here. That's not a thing, so that goes away. And then we start looping over stuff. We don't need to loop by type ID anymore. That's not a thing. We can just loop over all the assets and find the assets that we actually were trying to output. We don't need to do this, right? So here is the actual thing that we're doing. We can just use the asset index. We can start at 0, and well, we can skip asset 0 if we want to. And I'll call this, this is really global asset index, right? So let's just call it global asset index. We go through all of the assets. And for each one of those, we see if it was in this file. If it was in this file, then we go ahead and write it out. Asset index in file is going to kind of be assigned going upwards. And what we want to do here, because we're resetting this asset array, we probably should reset the asset's idea of which asset it is as well, right? So in other words, in here, we sort of have the source asset that it came from. It's got an asset index in file value. We want to set that to be the new asset index in file, right? Because that's where it is now. We could have moved it, right? Usually we won't because we're going in order, but just in case, we should store that information, right? We could alternatively assert that, but I don't know that we care about asserting it because we just care that it lines up correctly, if that makes sense. So anyway, here we are with our, do we even use that information now that I think about it though? It doesn't matter. We'll look at that later. All right, so anyway, moving forwards, looking at what we're actually going to output here, we've got sort of this dest information. Let's look at what's actually stored there. So here's our HHA asset. We now need the information that's going to come with this asset. We don't need any of this stuff, right? Because it's basically all yeah, this is all for the type. We don't care about that at all, right? That's gone. Goodbye. Not relevant. So all we need to do is copy the HHA and then update our tags, right? Because our tags, the tags are going to get repacked now. They might not line up the way that they used to, so we're just repacking our tags. So we grab the source HHA out. Then all we need to do is just like pack the tags in there. The first tag index 1 past last tag index bit, shouldn't that have been updated? Is there a reason we weren't updating that? Does anyone know? Does that look, that looks wrong to you, right? Does that not, I mean that's definitely, that's got to be wrong. I don't see any way for that not to be wrong. This should say first tag index equals tag index in file. And this should say when passed, last tag equals tag is in file, right? I mean, that's just seems pretty obvious to me. Unless I'm missing something. Anyway, so that's a much simpler loop now. That builds our entire asset array information up. And so now what we need to do is account for the fact that annotations were never included in here. Again, not particularly difficult. We should be able to just say, HHA annotation, dest annotation equals annotation array plus asset index in file. And then we can literally just, I don't even think we need to update anything in it. I think it's literally like this. I mean, I think that's it. Because all of it is just some indices and some, you know, checksums and stuff, and they'll just copy over, and they're correct, right? So that they're just going to reference into the file as and the file hasn't been touched in terms of the data that's in it. So I feel like that's just fine. There really isn't anything else to deal with in there, right? So that seems totally fine to me, and I think that's really all we needed. So that should be fine. Oh, you can hear, must be time for the Blue Angels. I can hear jets outside. So that all seems totally reasonable. Last but not least, to complete this, we get, you know, obviously besides debugging that, what we need to do is go and make it so that when we pack in a new asset, so in here, for example, when we're going through, when we pack in a new asset, we need to add information into the annotation to account for that, right? So if you look in here, right, we come through and we say we're going to put a new asset into this file or whatever else it is that we're doing here. So we're going to grab a new asset in, and what we need to do is we need to reserve the asset data for the stuff that we store, right? And so what we want to do here is make sure that the HHA asset data size gets updated to reflect the new data size, right? And this, in fact, when this does this, it's less about, we don't really need to worry about these two dimensions anymore. We can actually just check the size. So if it doesn't have storage or wouldn't fit, then we need to update it, right? So that's how that works. Then this stuff just passes on through, and everybody's fine and dandy, and that's all nice. So that's fine. But then you can see here, when we set up this HHA and we place the stuff in here, when we write the asset data out, we don't write out any annotation information, right? So what we need to do here is we need to make sure that we're actually going to store the information for this assets annotation properly. So in order to do that, we kind of have two things that we want to do. So the first is we need to fill in all of the pieces of the annotation that are relevant to us, right? So when we come through here and we get the asset out, if we had an actual asset, then we'll inherit what its annotations were at the moment, and that's good. But we also need to say, look, the annotation itself has a bunch of stuff we may need to set, you know, based on what we're actually doing here, okay? So here's all the stuff we may need to set, and let's make sure we set it. We need to set the source file date for sure. We need to set the checksum for sure. And then we need to set the sprite sheet stuff for sure. Like, that's always going to be updated because all of that stuff has now been updated. Maybe it's the same in the file, maybe it isn't, but we it can't hurt to overwrite something with the same value that it used to be, right? Then we've got our 4 strings, and we have to decide what we want to do with those strings, but that's sort of a separate issue that we'll get to in a second. So we need to specify this information, and this information needs to kind of come in as part of this process. What we don't have right now is a convenient way for that to occur. What we should do is we can get some of it out of here. So the checksum information, that sort of stuff, can get updated here. Let's take a look at how that would work. So if we look at what's going on here, when we come through here, we set the date, and we say, do we want to do this before or after? Now we can sort of have a good reason to do it. So we can basically say, we update this first because assets that get packed from here on out need to be able to stamp themselves with the right data, right? So what we need to do here is we need to set these two. We'll want to talk about that checksum if we end up doing that. That'll want to be set here as well. We have those 2 pieces of information. And they're ready to go. What we need to do now is just copy them in. We have the source file here. It's this file, just the file pointer, right? So we can say file date, file checksum. Those are both there. Sprite sheet X and Y, we know what they are. We had to figure those out. They're Y index and X index. So we can just copy those in directly. And so then we're really just left with 4 strings. Question is, where do the 4 strings come from? If you look at what we're dealing with here, these can we can deal with in one of 2 ways. We can be maximally piggy about it, and put the pig hat on. We could choose to be more efficient. It depends. Because these strings are going to appear multiple times, right? So the author for a large number of assets will probably be the same. Like Anna has drawn all of the ones that are in the directory currently. So all of those would have Anna Retberg as the author on them, right? The source file name is going to be the same for every sprite that comes from the same sprite sheet. So we don't really have to write those strings multiple times, right? But again, optimization that we don't necessarily want to make yet, because why complicate our code when we don't actually need to deal with it quite yet? It'd be pretty easy for us to just make something that does a string compaction. Like we could put that in HHA edit. We could have an HHA edit thing you run that does like an optimization pass on the thing. That seems better to me because then we're not worrying about if we've got like squirrely little errors in here, right? So so I'll put a to-do in there. We can choose to address it in the future if we want to. We don't necessarily have to. That's kind of up to us. So then what I'll do is I'll do a write asset string call. This directly mirrors the one that we already did in the HHA edit, right? It's the same thing. And what this is going to do is this is just going to let us write these out a little bit more compactly. Actually do it this way. Where's write asset data? So I'm going to say write asset string, and then I'm going to give it the count and the offset. Those are going to go like that. And then I just need the information here. We should have access to that information, but we don't. And so one of the things we're going to need is we're going to need some additional information. We're going to need a way to get that additional information that we don't have right now. And so I'm going to just introduce a little thing that's like, import annotation. I'm just going to introduce some strings here. I'm going to say that we've got a asset name, let's just say name, description, and author. I'm going to say that we've got those and that those will come in along with the rest of the import tags. So, we'll say this. Actually, you know what? Import grid tags could actually have that on it. Where did we define that? How come my search didn't work? I must have typed it wrong. So with the import grid tags, I'm just going to put it right there. Okay. So I'm going to do that, and I'm going to come back here, and I'm going to just do a little bit. I might clean up some string stuff too while I'm at it. We'll see. So what I want to do here is say, all right, we know that the grid tags have this information on it. So I want to write this asset string coming from the grid tags that we have. So here's that grid tag array, right? The grid tag array has a name, description, just not the sender height, and author. And so we've got these three here, and what I want to do now is just match these up. So we've got the name count, asset name count, and this is asset name offset. Oops, I did that wrong. This is description. And then finally, we've got the author. I think it's just author count. Something like that. Assets, array size. And that should be an annotation. And this was called annotation array. There we go. Grid tags were a pointer. And off we go. So our final write asset string is a little bit different. This one is the source base name, right? What's that called again? Source file base name count. So off we go. If we had a lot of these, we'd probably introduce a file string class that somehow tried to deal with that. Not a class, but a struct. Problem is you want them separated, so it's kind of hard to do. It's a long story. Anyway, so when we deal with this, the only question we have now is where is that going to come from? And the answer is that comes from the file. It's right here. Problem is base name is actually an ASCII Z string. We'd rather this not be. We'd rather it just be a string. So I'm just going to go ahead and make it a string, and we're going to deal with the implications of that later, because I want everything to be a string now. Since we introduced that string type, I would like everything to be it, because I like those better. I like counted strings better than ASCII Z strings. They're just easier to use. So anyway, I'm going to say base name in here, and off we go. So now we've got our write asset string. That will write out all of the strings. And so all we need to do for that is actually have one of those, and it's going to mirror our write asset data. So right here, It needs to take the asset file to write to, and then it needs the source, and then it just needs to know, hey, you know, what are we gonna actually write into? And what you can see here is we're gonna have to call reserve data, so we're basically pushing the data out each individual time here when we write this out. And you know, we could actually see whether it fits in the old location that the annotation was. I don't know that I'm super motivated to do that. I really just don't know how I feel about that. Let me show you what I mean. What I mean is this. If the source count is less than or equal to the count, this would not need to be reserved, right? But if it's the other way around, it would be. So if the source count is greater than the count that's currently there, then the count that's currently there needs to become the source count, and the offset that's currently there needs to become a reserved data, right? So the reserved data, this would need to take the assets, the game assets, like so, right? And it would need to reserve that much, however much that is, right? So the count would need to get reserved. But then when we're done, then this just calls write asset data, and it just passes the file and the source data that it's trying to write, and just says, look, write to this location, this amount, and off you go, right? Another way to look at this would actually be, it's a little bit simpler to perforate the code, because I would have to set the count. Since the count has to get set in either case, we could just do this. Like, look, the count's always going to be set. So the question is just whether the offset is set. And so we just do it this way. So meaning if the source count doesn't fit in the space that was already used for whatever this annotation is, then we reserve the data for the new space, and it goes there. And then regardless, we're always going to change the count to be whatever the new count is. And we're going to write that out, right? So it kind of looks more like that. We always write the count, and then we always write the data at the offset one way or the other, right? That seems okay. You know, it seems okay. I guess is all I can really say. This has to be a U32 in both cases, but that's okay. We know we're not going to have strings longer than that because that would be ridiculous. You couldn't even display them on the screen. I guess I should have made that still be this. So anyway, that writes out our data. Moving through here, we now have to deal with the changes that we made for the base name stuff, right? We need a way to copy on the regular kind of string there. We can do that pretty easily. Let me take a look at what else we got. So this has to take assets now. And so really we're just down to the checksum and being able to push that string onto the stack there. When we're actually, I guess that strings are equal. So that, yeah, that all just works. So what we need to do is we need to have a thing in our memory. We've got the push string call here. And what we want to do is probably have a inline. I don't know why we bother ever typing inline. The compiler doesn't care. So if I do memory arena, and I do something that's like, here's the length, here's the source. What I can do is just make this thing trying to think of how I want to do this. That's kind of more of a push string Z. What I might do is just say like that, you know? and then regular push string will is what I want to actually move to. That'll do the other kind of push. So if we do push string, memory arena, star source, then what it'll do is basically the same thing here, where it takes the string length. I don't know why we don't just use string length here. But then we push the size on there and we and copy, right? And do we have a push copy? We do. So a push copy in this case would actually be what we want. So really, we can make this much more simplified than even that, right? What we can do is say this is just push string is just a pretty basic. We just say, look, here's the result. The result count is however long that thing was. The result data is just the push copy. Right? I mean, that's all there is to it. It's pretty basic. So returning a string here is maybe a little harder because it doesn't look like it knows what a buffer is. So I guess that needs to be defined earlier, potentially, which is fine with me. Copy is something that's probably in here. I don't know where we put copy. That should be in memory anyway. I'm not sure why it's not. Oh, it's just defined lower down, right? So copy should really be up at the top because anybody who's doing memory pushes might need to use that. So that should actually be up here. And then I think we're good. So there we go. So now we're just down to checksum. I don't know how much time I got left. I guess I got about 10 minutes left. So the last thing we would want to implement here is the checksumming. And you know, we've read the data in, so you can see we've already got a file buffer. So really what we want to do here is say like checksum of and pass this file buffer in. And so what we want to do is have some way of asking when we have a file, you know, what's the checksum? And that can be a shared call. That can be something that goes in here, where we say, you know, give me back the 64-bit checksum of whatever this thing is. And we just need some way of producing this actual checksum. What is a checksum? Well, a checksum is a number that's basically, you've seen us do stuff with exactly this. It's basically a hash value, right? They serve exactly the same purpose. It's just they have slightly different criteria for which they might want to be judged, right? So in both cases, in a hash value and a checksum, or another name for a checksum in a lot of cases is a hash value in the cryptographic sense, right? So cryptographic hash, there's a lot of names for things that are basically very similar. In all of these cases, we're talking about roughly the same thing. We're talking about taking a very large amount of data, an entire file's worth of data in this case, but in a hash, an entire string or a bitmap or whatever, we have a very large, several K, several megabytes, several gigabytes even of data. And what we want to do is we want to reduce that data down to an incredibly tiny size compared to its original. Why do we want to do this? Not to use it, because we can't, right? It's not compression. We can't get the original back. So we're not trying to make a smaller version that we can then expand to the original version. No. We're just trying to come up with a number that in some way identifies this larger piece of data. Why do we want to do that? Well, the reason is because in the hash case, we want to try and use that data to put it into a slot that can identify it more uniquely, so we don't have to search a whole linked list full of things to find it, right? We're trying to segregate out a set into different things by using this sort of ID value, right? So in that case, what a hash is trying to do is create a value that's likely to be distinct from the other things we will also put in the hash, right? In the file case, it's a little different. It's similar, but not exact. In the hash table sense, what we wanted is we have many disparate things. They're totally different, right? A set of strings that are not coming from the same place. One is Casey, the other is Carl or Lemongrab, right? And what we want to do is file these into nicely segregated buckets. If we have 10,000 strings and 1,000 buckets, what we want ideally is for 10 strings to go in each bucket. We want a perfectly distributed by our hash buckets, right? So that's what we're trying to do. But they're disparate things, totally different. Casey and Lemongrab are totally different strings. For our checksumming, not so. Checksumming is for a different purpose. It's to try to take two things that are probably very similar, that have only had slight changes made to them, and determine whether there's any difference. So what it's trying to do is it's more trying to pick up subtle differences. So if I said lemongrab and lemongrass, I want those two to hash to something distinct, much more so than I would ever care if Casey and lemongrab hash to different things. Why? Because I'm expecting my art files to have small changes made to them. I'm expecting artists to make small changes and then resave them. I'm not expecting them to be completely different every time. So I would almost rather something that doesn't quite have the same usage as a hash in the hash table sense. It's not the same thing. Oftentimes, good functions can do both. They're not completely different problems. They're very similar, so it's not a super disparate thing. But the end goal is not quite the same, I guess is all I'm trying to point out. All right. So what would this look like? Well, first of all, we literally could do this, right? We literally could do this. If we wanted to store the checksum, we could literally say, look, let's just straight up store let's straight up just use our string hash. It would work. But I think we would probably want something better. We would probably want to look at some cryptographic hashes. They're more sensitive to trying to make small bit changes guarantee that they produce different hash values. And so that would be more probably what we would want. Something that's more about preventing small changes. Here's the thing. I put the hash stuff in as sort of a just in case we want it. My question that I have is, do we really want it? What's it going to do for us, right? Because I don't know that it's really going to do anything for us, right? If two hash values matched, how would that help us? We still don't really know. It could have been a hash collision, right? So I don't really know. It seems more like you would want to match the asset data and see if the asset data changed. I don't know. So we can use a string hash. We can use the checksum, or we could not. I'm not sure how much we care about that, but this is where we would do it, right? Let's just finish that up here. Where is our shared? Let's see here. String hash of. There we go. So what I would do here is say, okay, here's our string. And that would give us a checksum, right? It's not a good checksum. It's not the one we would want, but it is actually a checksum. Okay? And again, the reason for that is just because, look, anything you do that mixes all the values together somehow is a checksum, right? If you change some of the values, it might change. There's better and worse versions of it, and we could look at using them. For example, a common one in this case might be what's called the Blake hash. Oops, not black hash, Blake hash. There's probably also something called a black hash. There's red and black trees, for example. The Blake hash is an example of a hash you might use for something like this. And they oftentimes will produce bigger hash vectors as well. So in this case, you can see this one is what, like 512 or 256, right? So if we wanted to, we could support bigger hashes, and that gives us more resilience. The bigger the hash value, the more of the data you're sort of checking, right? The wider, the less likely you are to be able to have a collision, right? But at any good hash value, you can always truncate, so you can also just take the first two from it, and there's your 64-bit hash. So you can always, you can always do sort of subgrade hashes if you want. So we could do a Blake hash. There's also obviously the ones that are sort of the government-approved versions, right? Which is SHA. I think SHA is not probably as good for our purposes. I believe SHA is more... I can't remember now that I think about it. I'm not going to say that because I don't really remember. I haven't looked at Blake very carefully, so I'm not going to make that statement. There's a lot of hash values out there. We could also use something more like a murmur hash, which is a faster hash, so that it doesn't take as long to import things and check the hash on them. So we can do a lot of things. We'll pick that up tomorrow and see what we want to do. For now, we have a crappy hash value in there, and what I could do here is just make sure we put the to-do in there. Where is our shared? It's down at the bottom of this, right? But I think that's basically it. And I guess I'll run this, but it shouldn't do... hopefully, we should still run just fine, because, again, it's not importing anything right now. We didn't make a local file for importing, so we should be good to go. I'll go ahead and go to the Q&A now, but I think we've got most of the stuff into position that we needed. I think we redid all of the import-export stuff, so tomorrow it's basically just... We should probably put in a better hash function if we're going to use one at all. Put in a better hash function there. Maybe make a little more space for it. Like maybe we want a 512 size hash, I don't know. But we can put in a better hash if we want to, and then we can start the debugging process on that, on the all the stuff we did. A blind orphan. How often are assets updated? What are the performance characteristics you're aiming at? So mostly, I guess what I would say is the assets are loaded by the artist, and so you don't want anything too slow that will annoy... Like, you don't want the artist sitting around waiting. So if you have a problem with... If you've got something that's so slow that you don't actually... that you're actually costing the artist time, then, you know, you've got issues. So you don't want to do anything obviously stupid. But beyond that, we don't care. We don't need this thing to do anything high throughput. Assets will only be updated one sprite sheet at a time, particularly. So basically, an artist saves a sprite sheet, we load the sprite sheet, we want that to run in a couple seconds, right? We don't want that to be, like, basically think of it as a build. When we run a build, if it takes 2-3 seconds for us, we don't care, right? That's fine. If it takes 10 seconds, If it takes 30 seconds, really bad, right? And if it takes like minutes, that's awful. So we don't care if we're 1 second or 3 seconds or half a second. Those are all probably equivalent to the artist in terms of time. If we're 10 seconds or over, not great. Not great. So I would consider that an issue. If our import took longer than a few seconds per sprite sheet, I think we would need to optimize that, because that's not an acceptable turnaround time for the artist. Would you suggest any resources that cover modern C++ memory management very well? I tend to overuse unique pointer. Basically, C++ memory management, modern C++ memory management is awful. Don't ever do it. If you're trying to learn it because you're working at a job, hopefully they just sort of have their own policy about what they're doing and just follow that policy because you have to. But modern C++ memory management is awful. Don't ever do any of it. It's all by people who don't understand memory management. Full stop. Modern C++ memory management is worse than garbage collection. If you have a choice between C++ memory management and like C#, C# probably smarter. It's probably better. It's probably better performant too, honestly, in most cases. Modern C++ memory management is terrible. It's really, really, really bad. It's extremely bad. You already have an Adler32 function written out in the PMG partner. Why not use parser? Why not use that? Did we do that? Where did we do? I don't remember us implementing that. Where is that? I don't remember doing that. GG Nate, where do you think we implemented Adler32? I only work on this on the weekend, so I may well have forgotten. But if I wanted to run the game locally, is the steps I need to run the test asset build first, and then we could run the HA edit to update to v1 if we wanted? Yes. Looking at struct HHA annotation, could we append the authors of assets into the credits for the assets in the current run of the game? You could, yes. Martin says, pre-stream off topic, GL swizzling with GL texture swizzle RGBA. RGBA works fine with GL v3 and 3.3 higher, even for core profile. Before 3.3, it works only if the extension is present. So you get whatever channel into any channel you want. Really? Is this another one of those things, Martins, though, where you have a magic computer where this works and I don't? Because that's what happened with I/O control ports. I'm sorry, I/O completion ports when we were doing IOCPs. I didn't really test that maybe as thoroughly, though, so that may be true. That's good to know. If GL Texture Swizzle RGBA works fine with 3.3 higher, that's probably fine for a lot of purposes. For our purposes, that'd probably be fine. In Handmade here, I think we require 3.3 or so. But that's good to know if that's actually true. Nordic player, I do not have any thoughts on the Rust programming language. I don't use it. I thought you added it along with the Huffman compression. I don't think so. What? I mean, if you can find it, let me know. What would we have been doing? What would it have been doing for us that we would have needed to implement it? Martins says it's in the core spec. Okay. Well, that's good. I mean, that's good that they have that because I kind of missed it. It was really nice when they used to have it. I may have just been using OpenGL 3 and didn't have the extension or something in a weird case, and so I thought they'd removed it permanently. But it's good to know that it's back because it seems pretty useful, right? Wintermute 87, is C++ memory management bad for games or just bad? Just bad. If the latter, what's a good general purpose memory management strategy for C++? So in my opinion, there's really only two sort of memory cases, right? There are things that behave like stacks and things that behave in random fashions. And everything that can behave like a stack should be made to, in my opinion, which is 90% of all allocations should be done that way. And you should be doing them that way, with arenas, basically. The other 10% should be done probably with free list management. So that's what I would do in C++. I would not use any of that unique pointer, shared pointer nonsense. Those are just garbage. RAII and all that stuff is only for toy programming. It's like when people use that stuff, they don't know what they're doing. Sorry, I know I'm stepping on a lot of people's toes out there who are experienced programmers who say that these are smart things to do. They're wrong. I mean, they just are. You spend a ton of time, your C++ code just does tons of work that it doesn't need to do, you know? So on Handmade Hero, we don't quite go full pull. Like on Handmade Hero, we are not quite as good as we should be. We use arenas, so we get a lot of win out of that, but we don't really implement much more on top of that for the more general purpose kinds of stuff, right? So we only can only do certain things on Handmade Hero, right? It's a limited scope thing, and there's only so much we can do. But the stuff we do with arenas on Handmade Hero is kind of similar to what I think most memory management should look like in most things, most of the time. Because most of the time, what you want to do is you want to be working in temporary stacks. Most things can be implemented that way, and they're very, very fast. When you want new memory, you just push forward. You don't need to do anything. There's no mutexing. There's no looking into tables. There's no nothing. You just go, can I fit it? If yes, it just goes. It's like an if or two to go. And that's really important. And then cleanup is instant. You just roll back the arena pointer. So you don't have to go through all of these pointer chains freeing everything, which is really, really bad, right? That kind of stuff is just bad programming. When you're crawling through pointers, freeing things that you don't need to do because you know you can clean up everything in bulk, that's really bad. You're wasting a ton of time, right? A ton of processor time doing nothing. Once you get rid of all that stuff, then you're left with just things that stay around for like unpredictable amount of times. So like we're allocating something and we don't know when it's going to be deallocated. And for those, you need more thoughtful approaches. And that's the place where if you were using garbage collection or something like that, I'd be like, fine, that's fine. Like, you know, it's probably not how I would do it, but it's fine. Or if you're using something where you were using some reference counting, again, that's fine. Like, there are cases where things like that do become okay and they are reasonable and they aren't costing more time than they should and so on. But that's the only place that I ever want to see those sorts of crawly-based pointer-looking things, like the way garbage collection analyzes, like the way modern C++ does all of its stupid, unique pointer, shared pointer, smart pointer kinds of things. All that stuff should only be happening in the case where the memory lifetime isn't known. And the memory lifetime for almost everything in almost every program is known. That's the part that's so frustrating. People act like we don't know when the memory is going away. We almost always do. Like 90% is even probably low. Like 99% of all memory, you probably know exactly how long it needs to be there at compile time, right? And it's just ridiculous to write code in a way that pretends that everything is volatile and completely arbitrary. That's almost never true, you know? And so all of that modern C++ memory management is just based on bad understandings of how memory works. And it's about focusing on the language, not the hardware, which I find to be a grievous error. Do you use any of the handmade code in your 935 project? I don't at the moment, but I will be moving the PNG parser in there. Now that I have my own PNG parser, I can use that one. Currently, I have a thing that I have a PSD loader, and that's what we use for everything. And I don't have a PNG or JPEG loader. So for our website, which is the only thing that loads PNGs or JPEGs, for our website, I actually still call out to like external tools. Like the web builder will like call possibly like free image, I think. It'll call like a DLL to put those into other formats. And now I can just switch to using our PNG ourselves. No, sorry, it's not that. It's not free image. It's image magic. It calls out, like if it needs to produce like multiple sizes of a thing, and it was the website stuff, so I was kind of in a hurry. So all I do is I shell out to image magic's convert utility so that no matter what the input file format is, it would resize it down. We only use PNG and JPEG, so what I'll probably do is at some point write my own JPEG, and then I can just have it entirely in our code base, which would be nice. That's like one of the only things we use right now. There's like two external calls we make in our entire code base right now. One is for that, which is the website, so I don't really care. It could stay that way. I don't really care about that. But for 1935, we do use one external tool. That's a Vorbis compressor. And so someday I'd like to put in our own audio compression, because Vorbis sucks anyway. So I'd like to put in our own audio compressor at some point, but that was just a bridge too far. I'm already always swamped with coding work on 1935, and I just couldn't afford it. So, but someday I'll get there. Illuminator, will you be changing your fonts to be packed bitmaps rather than a bitmap per glyph? If not, how would you store the UVs for the glyphs in the HHA file? No, we probably wouldn't bother because we don't really have to. I mean, maybe we would at some point. I'm not sure. But if not, how would you store the UVs for the glyphs in the HHA file? Well, so the same way that we store the glyphs now as just an array of bitmap indices, you could just store the bitmap index and the UV, right? Have you tried the Opus codec, by the way? No, I haven't. Is that the one that's lossless? Or is that just the new one that they made? What's the lossless one? It's not Opus, is it? It's Flax. That's the one. So no, I have not tried Opus. Is it necessary to use pragma pack, push, and pop for the HHA structs? It is sort of. The reason that it is sort of is because we don't want different versions of different compilers deciding to pack those structs differently. And so we're just trying to make sure that if other people are compiling them on, say, a 32-bit compiler or something that might make a different decision about how it got packed, they would say the same. Are there any things in there right now that I think it would affect? No. So I don't think we need it at the moment, but it's a really bad idea to roll the dice on that. Like, you don't generally want to start making a file format in something that doesn't have the C packing rules turned off, right? And yeah, just to expound on that a little bit, since people are talking about it in the chat, the reason that I say Vorbis sucks, it's not the compression quality or amount that sucks. Like it's acceptable for use. You can compress things pretty reasonably and they still sound okay. So I feel like it's competitive with MP3 just fine, which is obviously a standard that everyone finds acceptable and uses for everything. So it's a reasonable replacement in that sense. The problem is it's just crappy code, right? It's built in 2 layers for no reason, right? So the Vorbis, if you use their code for it, what ends up happening is you have to have it encode Vorbis output into OGG streams that can be broken up into packets and all this, right? None of that stuff I want. Like, I have a game. It's got its own streaming system, its own file format. It knows where everything is. It just wants you to output, right, data that it can quickly decompress with a nice, clean, easy, efficient code stream into sound data again. And it really just isn't set up for that. It's got way too much complexity. The OGG part is just bad, but you have to use it more or less. And so even if I was going to stick with it, I'd probably make a thing that parses out the OGG stream that comes out of the compressor and re-encodes the Vorbis part, and then write my own Vorbis decompressor part that just went directly to bypass that kind of crap. Because it's got a bunch of cruft you just don't want. So fundamentally, the compression model, I'm not an audio compression guy, so I'm not in a position to say whether it's good or bad, right? So I'm not complaining about the compression quality. I'm complaining about the code quality. It's just not suitable for what I want to do. And so I would much rather have a code base I control so I can make a really nice, clean, efficient decompressor part. That's the important part. Martins was posting some stuff about Opus. So here's a question with Opus, by the way. What is the actual code complexity level? Because that's the other thing that I find is problematic with audio codecs a lot of time. I mean, here's the thing, and a lot of people don't understand this fundamentally, right? I don't care how complicated your compressor is, really. If I got to use a library to do compression because I ain't going to do it, and it's super complicated, whatever, right? I don't want to have to use a library to decode stuff. I want to be able to write it. And I want it to be simple, right? It shouldn't be complicated to do a decode. And so I want to see like a 5,000 line decoder in one file for your audio compressor. If you can't do that, you've got a problem, in my opinion, right? And yeah, FFTs can be a little bit nasty, and there's a lot of audio codecs that rely on FFTs, and so I'm gonna cut you some slack on stuff like that. I don't mind, but it should be basically straightforward compared to any reasonable audio codec decoder. And if you're coming to me and going, look, we can get 10 to 1 if it was a simple 5,000 line decoder, but we really wanted to get 11 to 1, and it's this giant 50,000 line decompressor. That is a really bad trade-off, right? There is no game that I can ship with 11 to 1 compression that I couldn't have just shipped with 10 to 1 compression. It affects me not at all. So really what it did is made my code base worse, made it more likely to have bugs, and made it harder for me to maintain. Because now there's this giant 50,000 line wart sitting in there that I don't know what it does. I can't evaluate it very effectively. Porting it can be problematic. It may not work properly on all processors. I have optimization problems now because I got to worry about how 50,000 lines of code is being executed by something, right? So these are bad trade-offs, in my opinion. So audio codecs, I think once they get above some magic number, I'm not sure what it is. Let's say it's 8-to-1-ish, maybe 10-to-1. Somewhere around there, I don't want any more complexity. If it takes more complexity to get further down than that, I don't want it. You're making a bad trade-off for me. I understand why you're doing it because you're making an audio codec. You want it to be as compressed as possible. That's your whole thing, right? The highest quality, the lowest data rate. But that's just not what I want. So you're giving me features I don't want or improvement optimization in the data rate that I don't want, and you're making it worse for me on the integration side. So that's really crucial to understand. I want a very simple decoder that I can write myself in a couple weeks, right? Let's say from your spec. I want that. So if they've got that, I'm happy. I would be happy with that, right? That's really all I have to say about that. Vorbis is not that, right? Yeah, 47,000 lines. Yeah, so 47,000 lines is just way too big for a decoder. I guarantee you it's not worth it, right? It's worth it for some people, meaning if what you're trying to do is maximally get the highest quality in the lowest space and accept no substitutes, you know, we're sending the probe into outer space, then great. But for a game, it's just not necessary. If I can't fit the decompressor in like less than 10K of code, I don't really want it, right? And so I would like to make a simpler audio codec, one that just gets 8-to-1, 10-to-1, whatever, something reasonable, shippable, but simple. 5,000 lines, 10,000 lines, no more. That would be my sweet spot, and that's what I would be aiming for to replace Vorbis with. Which may just be basically Vorbis. Like I could just do more or less Vorbis, right? But trim out the fat, and maybe it gets there. I don't know. Opus might be similar, right? Like for all I know, if we went and started looking at Opus and how it worked, it may be like, yeah, okay, so if we just get rid of certain modes that it does, like maybe it's got all these different things it can do, like, oh, this looks like speech, so I'm going to do like a speech codec here, and oh, this looks like music, so I'm going to do a music codec here, and oh, this looks like this, and it's got like all these crazy things, and maybe they're really disparate, and maybe we only care about like picking the one that works best and just using that for everything, even though it's a little less efficient for some things. You know, it may be that you could make a simplified Opus that could still work, right? And so that's like totally viable too, right? So I don't know, but at some point I would like to figure out how to do that because that's a really big nasty wart in our code base right now that I don't like. So, all right, that said, we are done for today. Thank you everyone for joining me for an episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along the series at home, you can always go to handmadehero.org and you don't need the /game on there. That's just what happens if you click this. Go to handmadehero.org and you can pre-order the game. It comes with all the source code so that you can play around with it yourself. We also have some other useful stuff here. There's a watch page where you can go to watch the series. It's got a viewer on there that anytime we're live, it comes up. Otherwise, it'll show you the schedule so you can know when we're going to be live next. It's pretty handy. It's also got an episode guide you can use to watch old episodes, and it has search by keystring. It's awesome. You can just type in stuff. You want to know where we did the PNG decompressor, just type PNG in there. It's got it all. It's pretty great. We also have an FAQ if there's any questions about the series you have that are easily answerable. And finally, we have a Handmade Fund if you want to support things such as that awesome episode guide or the forums that people use at Handmade Network, stuff like that. You can always contribute to the Handmade Fund. We give that money away every month. However much we get, we give away to the folks doing useful projects for people who do handmade hero-style programming. That's it for this fine Saturday. We'll be back tomorrow for another stream. Probably tomorrow we could implement the hash and then we're out of stuff. So it's just really debugging and the hash tomorrow. And then we're into that nasty tag problem that I talked about at the start of today's series. Not looking forward to that, but hopefully we will get lucky and be able to come up with something that works pretty well. We'll see. Until then, have fun programming, and I'll see everyone on the internet. Take it easy, everybody.